Okay, in this video we're going to work through some questions about purchase options. Question 1 says an electrical store offers its customers an 8% discount if goods are fully paid for in cash on the day. How much will Robin pay for a digital camera with a marked price of $729 if she pays for it in cash? Okay, so the cost of the camera is $729 and she's going to get an 8% discount on that camera if she pays in cash. So 8% of 729, that's the discount, this bit here, and that's the amount that she would pay without the discount. So we just take the discount away from the amount and put that into a calculator. So it's going to be 729 minus 8%. We've got to express that as a decimal, which would be 0.08, and then multiply it by 729. And notice that I've put the discount into brackets, so it will calculate that as one thing. 729 minus the discount equals 670.68. 670.68. That's going to be the price of the camera if she pays in cash. Alright, question 2. A department store offers its customers a 5% discount if goods are fully paid for in cash on the day. How much will Lauren pay for a home theatre projector with a marked price of $2,499 if she pays in cash? Okay, it's the same kind of problem. The original cost is $2,499. If she pays in cash, then she can take off 5% of $2,499, which equals, I'll write it out as we'll put it into the calculator, minus 0.05, that's 5% expressed as a decimal. You can turn a percentage into a decimal just by dividing it by 100. 5 divided by 100 gives 0.05, 8 divided by 100 gives 0.08. That's how you get turn a percentage into a decimal. So 2499 minus 0.05 times 2499. So we're finding 5% of the marked price. And when we put that into a calculator, we get 2499 minus 0.05 times 2499. That equals 2374.05. 2374.05 dollars. So there's question 1 and 2. Okay, question 3. Okay, in question 3, a department store offers its customers a 7% discount if goods are fully paid for in cash on the day. How much will Jan pay for an iPad with a marked price of $499 if she pays for it in cash? Okay, so again, we've got the marked price minus a percentage. We'll jump straight to the decimal version of the percentage, 0.07, 7 divided by 100, minus 0.07 times $499. Let's calculate it. $499 minus 0.07 times $499, 464.07. Okay, in question 4, Helen has a credit card with an outstanding balance of $18.50. If the interest rate is 18% per annum, calculate the amount of interest that Helen will be charged for 1 month if the balance is not paid by the due date. Okay, so this is a credit card problem. We're no longer talking about discounts because of payment in cash. We've got a credit card with an outstanding balance of $18.50. If the interest rate is 18% per annum, calculate the amount of interest that Helen will be charged for 1 month if the balance is not paid by the due date. Okay, so we're working out the amount of interest. The amount of interest for credit card problems is the simple interest formula, I equals PRT over 100. That's our starting point. Okay, the amount of interest, that's what we're trying to find out. So we're going to leave that blank. We need to know P, R, and T in order to work that out. Okay, the principal amount is the amount of the amount that's outstanding on the loan. That's $18.50. That's what we're paying back. The rate of interest is 18% per annum, and the amount of time, remember time's got to be expressed in years, we're looking at the interest that's going to be paid on 1 month. Okay, so 1 month, we've got to express that in years, would be 1/12 years, 1/12 of a year. That's 1 month. Okay, when we put these into the equation, we should be able to get the interest. Okay, let's put those values into this equation in the calculator. So P is 1850. We multiply that by R, which is 18, and we multiply that by 1/12, which we'll put in brackets, 1/12. Multiply all that together and we get that, and then we've got to divide that by 100, and we get 27.75 is the amount of interest. So for that 1 month, Helen will be charged this much interest if the balance is not paid. Okay, and the next question. Martin buys office equipment for $14.50 with his store card. So again, this is a sort of credit card, store card type problem. The card has no interest-free period, and interest is charged at a rate of 15% per annum. So straight away he's going to start getting charged 15% per annum. Calculate 1 month's interest on this purchase. Okay, so again we're calculating interest, and to calculate interest we use the simple interest formula, I equals PRT over 100. Okay, in this case our principal is $14.50, that's the amount that's owed. The interest rate we've been told is 15%, and we're doing this for 1 month. So we're only calculating the interest on 1 month. We've got to express that in years, and 1 month is 1/12 of a year, and all that's got to go over 100. So if we put that into the calculator, we should get the interest that he has to pay on 1 month. So $14.50 times 15 times 1/12. And notice I'm putting it in brackets because without the brackets the calculator would be confused about the multiplication and the division, the order to do it in. That way it should be very clear. Okay, and then divide that by 100 and we get 18.125. That's how much interest Martin will have to pay after 1 month. And because you can't pay fractions of cents normally, we should probably round that off to the nearest cent, which would be $18.13. Okay, next question, question 6. Fiona has a $2,000 outstanding balance on her Maya store card. So that's what she owes on her store card. The interest rate charged is 21% per annum. Okay, so that's important. On the balance that's unpaid by the due date. If Fiona pays $200 by the due date, calculate the balance owing. Okay, so she did owe $2,000, but then she paid $200. She owed $2,000 and then she paid $200, so now she only owes $1,800. So that's the first part. She only owes $1,800 now. Calculate the interest owing for the next month. Okay, so because she still owes this money, they're going to charge her some interest on that, 1 month's worth of interest. Sorry, this is part B, so I'll start a new line down here. Interest is I equals PRT over 100. And all we've got to do is enter in the values for PR and T into the equation, and we'll get the amount of interest that she owes for the next month. So P is going to be the outstanding amount on the balance, which is $1,800. She doesn't owe $2,000 because she paid off $200. The interest rate is 21% per annum, so put 21 in there. And the amount of time, we're just calculating the interest for 1 month. So in terms of years, it's going to be 1/12 of a year. 1 month is 1/12 of a year. And then all that divided by 100. So let's put that into the calculator. 1800 times 21 times 1/12, we'll put that in brackets, and we get that. We divide that by 100, we get $31.5. So she's got to pay $31.5 of interest on for the next month. So what will the new balance be owing on Fiona's next credit card statement? Well, she still owes $1,800, and now we've added on the interest for the next month, which is $31.50. So now she's going to owe $1,831.50. Okay, question 7. Noel has a credit card that charges interest at a rate of 12% per annum, but has no interest-free period. He makes a purchase of $1,750 on the credit card. After 1 month, Noel's credit card statement arrives. What will be the outstanding balance on the statement? Okay, after 1 month, the credit card company is going to charge Noel some interest because he's got this debt that he hasn't paid off, so they're going to charge interest on that. To calculate how much interest they're going to charge him, we use I equals PRT over 100. P is the amount that he owes, R is the interest rate, and T is the amount of time, which is 1 month, and in terms of years that's 1/12. We put all that over 100, and when we put that into the calculator, we get 1750 times 12 times 1/12, and we've got to divide that by 100. We get 17.5. Okay, so that's how much interest he's going to get charged, but the question actually asks what will be the outstanding balance on the statement. So this is the interest that will get added to his existing debt. So we've got to add his existing debt to that. And once we do that, we get 1767 and 50 cents. That's what he's going to owe. That's what the outstanding balance will be. Outstanding meaning what's still remaining. Okay, in the next part of this question, it asks the minimum repayment will be 5% of the outstanding balance. So the credit card company says he has to pay 5% of whatever he owes in the next month. So if we have to calculate the amount that Noel will pay if he makes that minimum payment. So he's just going to pay that 5% that he has to pay. How much will that be? How much does he owe? Okay, to work that out, we need to take 5% of the outstanding balance, which we just worked out was 1767.5. We need to do 5% of that, and 5% we need to convert that into a decimal by dividing it by 100. We get 0.05, and then we need to multiply that by 1767.50. Let's see what that is. 0.05 times 1767.5, we get 88.38. 88.38. So Noel has to pay $88.38 if he wants to keep the credit card happy by making that minimum payment. Okay, and the last part, Part C. In the next month, Noel makes purchases totaling $347.30. Calculate the interest charged and the balance owing for the next month's statement. Okay, so Noel, on top of his, he did owe $1767.50, and then he paid off this amount. So we've got to take that away from what he owed. Let's do that first. So 1767 and 50 cents minus the answer from the previous question, which was $88 and all that, and now he owes $1679.13. So 1679.13. That's what he now owes. Now in the next month he makes some purchases, these purchases here, so we've got to add those onto the amount that he owes now. This fella just can't stop spending. Okay, so on top of our answer from the previous question, we need to add on 347.30. And now we've got 2026.43. 2026.43. So that's what Noel owes now that we've added on these extra purchases. Now, calculate the interest charged and the balance owing for the next month's statement. Okay, so after another month, they're going to charge some more interest. So we've got to find out how much interest he's going to get charged if this is how much he owes, and then work out the balance owing for the next month's statement. So after we've added on the next month's interest onto that. So I equals PRT over 100. P is 2026.43. The interest rate is 12. And the amount of time is 1 month, which is 1/12 of a year. It's all over 100. Okay, when we put that into the calculator, so we've got the answer from the previous question times 12% and times 1 month in terms of years, and we get that, and we divide that by 100, and that's how much interest he's going to have to pay in the next month. So $20.26. That's the interest that he has to pay for the next month, and so that's going to get added on to his existing balance. So we need to add 2026.43 and 2026. Okay, so we've got 20.26 there already. We just need to add 2026.43 and we get 2046.69. So that's what his new balance is going to be, the outstanding balance in the next month's statement. Okay, in question 8, a second-hand car with a cash price of $25,200 can be bought under a hire purchase scheme for a 20% deposit and 120 $350 monthly installments. Calculate the total amount paid under the scheme. So the total amount is going to be the deposit plus all the installments. The deposit plus the installments. The deposit was 20% of the main price, which is a bit hard to see under there. So we need to work out 20% of the cost of the car. So it's going to be 0.2 times 25,200, that's the 20% there, just converted into a decimal by dividing by 100, times the price of the car, and then we've got to add the installments, of which there's 120 times $350 for each installment. So we've got to add all these things together, see what we get. Okay, so 0.2 times 25,200 gives us that, and then add 120 times 350, and altogether we get $47,040. $47,040. That's how much we're going to have to pay under this hire purchase arrangement, which you can see is significantly more than the cash price of the car. You have to pay a lot more for the luxury of getting the car straight away but not paying for it up front. So that was part A. The total amount paid, $47,040. In part B, we have to work out the total amount of interest paid. Okay, well that's easy, because the total amount of the interest equals the amount we actually pay, which was this, minus the cash price, or the, let's say, the normal price. So we've got to do what we pay, which is 47,040, minus what we would have paid if we'd paid up front, and that'll give us the difference, which is the interest. So 47 and 40 minus 25,200, the difference is 21,840. So that's the amount of interest. That's B. Okay, in part C, the flat rate of interest we have to work out. That is the simple interest per year charged. Alright, for this one, this is an I equals PRT over 100 problem. It's simple interest. That's the formula for simple interest. So the principal amount, or actually the interest that we're going to pay is that. That's how much interest we're paying. So that equals 21,840. And then we put in the values that we've got for these three things. So P, the principal amount, is the cash price of the car minus the deposit. That's how much had to be paid off after the deposit was made. So we need to do, we'll do this over here, 25,200 minus the 20% deposit, which is 0.20 times 25,200. So that's 25,200 times 0.2. Sorry, 25,200 minus 0.2 times 25,200. So the cash amount minus the deposit, $20,160. Okay, so that was the principal. That's the amount that had to be paid off after the deposit. And the rate of interest is what we're trying to work out, R. And T, the amount of time, is inside this amount here, 120 monthly installments. Okay, 120 months. We need to convert that into a number of years. So to convert months into years, if we had 12 months, that would equal 1 year. So clearly what we need to do is take the number of months and divide it by 12, and it will give us a number of years. So 120 divided by 12 equals 10 years. So our T in years is 10, and we need to put all that over 100. Alright, when we put into the calculator, we'll need to use the solve function this time. So we want to solve 21,840 equals, let's make a fraction, 2160. 2160 times R times 10 years, and put it all over 100. Okay, and then after you've put in the equation, just put a little comma there, and the variable that we're looking for, which is R, and when you press enter it'll tell you what R is. R is 10.83, and that was the interest rate, so it must be 10.83%. Alright, so when we solve for R we get 10.83%. That's the flat rate of interest in this hire purchase scheme. Alright, question 9. We've got a used caravan with a cash price of $8,990 purchased under a hire purchase agreement. A 15% deposit is made, and the balance is to be paid in 104 equal installments of $130 each. Now it's interesting that it hasn't told us here how often those installments are happening. Maybe we don't need to know. Let's see. Calculate the initial deposit. Okay, that bit's easy. if the cash price was that, and we've got to pay a 15% deposit, then we've just got to multiply that price by 0.15. That's 15% as a decimal. So when we put that into the calculator, times 0.15, we get 1348.5. That's the deposit we've got to pay. In the next part, B, calculate the total amount paid under the agreement. Okay, so if we're going to pay this deposit, 1348 is the deposit, and then we've got to add on all the installments that we've got to make, 104 of them, at $130 each. If we add the deposit plus the installments together, we'll get the total amount that we've got to pay. So let's do our answer, plus 104 times 130, 14,868 and 50 cents. Okay, so that's what we're going to pay for this caravan on this hire purchase scheme. When if we had the money to pay up front, we could have got it for much less, almost $5,000 less. In part C, we've got to calculate the total amount of interest paid. Okay, now if this was what we actually paid, and this is what the cash price would have been, the straight up price, then the difference is the interest. The difference is what we're being charged for that delay in payment. So we've got to calculate the amount that we will actually pay, and minus away from that the cash price of the caravan, and what's left over, the difference, will be the interest payment that was made. So 1486.5 minus 8990. The difference is 5878.5. $5878.5. So that's the amount of interest that we're paying on this caravan. Part D. Copy and complete the following sentence. If the payments are to be made over a 6-year period, the installments should be paid every how often? Okay, so what we know is that there's 104 installments that are made, and that they occur over a 6-year period. So if they happen at the same interval every time, then we can divide 6 years by 104 equal payments and see what we get for that. So 6 divided by 104, that means this fraction of a year, that's how often the payments are getting made. And we want to convert that fraction of a year. That fraction of a year is not very meaningful, so let's convert it into something a bit more meaningful. Let's convert it into a number of days. So if there's 365 days in a year, if we multiply that by 365, it'll give us a number of days. Okay, every 21 days is what that amount of time represents. So payments have to be made every 21 days under this schedule. 6-year period, 104 equal installments. We've just divided 6 years into 104 sections, and it was 21 days. We could also have taken this number here, and instead of multiplying it by 365 to get a number of days, if we had multiplied it by 52, we would have got a number of weeks, and that's exactly 3 weeks, because there's 52 weeks in a year. Okay, and the last, so should be paid every 3 weeks or 21 days, however you like to say it. Okay, and the last part, E, we had to calculate the flat rate of interest charged per year. Okay, so the flat rate of interest, to work this out, we've got to use the simple interest formula, I equals PRT over 100. In our case, the amount of interest is going to be the difference between the amount actually paid in the cash amount. That was this thing back here. It was part C. So that's the amount of interest that's going to be paid, 5878.5, and that's equal to the principal. The principal is what is the amount that had to be paid back after the deposit was made. So that's the cash price. After the deposit was made, that amount left over was the principal, the starting amount of the debt. So let's do 8990 minus 15% of 8990 and see what we get, what the original debt was. 8990 minus 0.15 times 8990, and we get 7641.5. 7641.5. That was the original debt, and that's our principal amount, 7641.5. Okay, R is what we're trying to work out, so we have to leave that as it is, and T is the amount of time taken, and it was paid back over a 6-year period. So time is 6 years and it's all over 100. Alright, when we put that into the calculator, we use the solve function, action advanced solve, and we'll put in 5878.5 equals, we need to make a fraction, so 2D fraction, 7641.5 times R, which is what we're trying to find out, and the years were 6, it's all over 100, and we've got to tell the solve function that we're trying to find R by putting a comma and then R. Okay, and then it tells us the interest rate, 12.82%. 12.82% per annum per year. Okay, in question 10, a new dishwashing machine is purchased for $985 on a hire purchase contract with no deposit paid, 6 months interest free, and 10.95% per annum flat interest over 18 equal monthly installments. Now we need to calculate the amount of interest that is charged. Okay, now this is made a little bit easier by the fact that there's no deposit paid. So straight away, we just go straight to $985. That's the amount that's got to be paid off, and it's being done in 18 equal monthly installments. So we use our equation I equals P over T, PRT over 100 to work out interest, and P in this case is 985 because we haven't paid anything off with a deposit, and the interest rate we've been told is 10.95% per annum, and the amount of time is 18 equal monthly installments. Well, in terms of years, 18 months is 1.5 years, and that's all over 100. So that turns out to be 985 times 10.95 times 1.5, and divided all by 100, we get 161.79. So that's the amount of interest that's going to get charged. Okay, well, if that's the amount of interest that we're going to have to pay back on top of the original cost of the dishwashing machine, then the total amount to be repaid is 985 plus 161.79. So we just need to add 985 to that, and we get 1146.79. $1146.79 is the total amount to be repaid. Okay, now finally, the amount of each monthly installment. If there's 18 equal monthly installments and the total amount that they're going to amount to is 1146.79, Then to work out what each monthly installment is, we just need to divide 1146.79 by the number of monthly installments, 18, and we will get the amount per installment. So 1146.79 divided by 18 gives us 63.71. That's the amount of each monthly installment. Okay, in question 11, we've got a hire purchase plan to buy a new TV and cabinet for that costs this amount of money, and we need to pay a $250 deposit along with 104 equal weekly payments of that much. We need to find the effective rate of interest. Alright, we need to use the equation to find the effective rate of interest, which we can get from the textbook or from the video if you've watched the video on this topic. And that equation tells us that we need to do 2,400 times the amount of interest divided by the principal amount multiplied by m, which is the number of monthly repayments, plus, should be a plus 1. That'll give us the effective rate of interest. Okay, so in order to work this out, we're going to need to find I and P and M. Okay, I is the amount of interest that gets paid, and to work that out we need to work out how much is actually paid, the actual payment for the item, and minus the cash price, the sort of normal upfront price, what that would be. So the actual price is going to be the deposit plus the installments. That's going to be the actual price, and the cash price we were told at the beginning is $13.90. Okay, so the deposit, we've got to fill in these values here. The deposit was $250, and the installments were 104 weekly payments of $13.50. So 104 times $13.50 minus $13.90. Let's put that into the calculator. So we've got, let's move the calculator over here, we've got 250 plus 104 times 1350, and then we've got a minus 1390 from that. Okay, we get $264. So that's how much above the actual price of the item we have to pay. So that's the interest. Alright, now we also need to know the principal. The principal is the amount that's going to be paid back after the deposit, and that would be the amount of the principal is going to be the cash price minus the deposit. The cash price is $13.90 and the deposit was $250, so that's going to give us a leftover amount of $11.40. So that's our principal. And finally, the number of monthly repayments. We know how many weekly payments there are, so we need to convert that into a number of months. Okay, 104 weeks. It's hard to convert weeks directly into months because there isn't a definite kind of conversion factor. But what we can do is turn 104 weeks into years by dividing it by 52 weeks in a year. That gives us 2 years, and then in 2 years we know that there's 12 months in a year, so there's exactly 24 months in 2 years. So we know M is 24. Okay, so now we've got our three values that we need for this equation. So we can put 2,400 times 264 instead of I, and for P we can put 1140, and for M plus 1 we can put 25. It's 24 plus 1. Alright, when we put that into the calculator, let's see what happens. Okay, so we've got a fraction with 2,400 times 264, on top, and on the bottom we've got 1140 times 25. And that turns out to be 22.23. And that's a percentage. That's the effective interest rate given these conditions in question 11. Okay, in question 12, we've got to calculate the real effective interest rate for question 8. So we're going to have to go back to look at question 8 and comment on the results of that. Okay, so here's all the info from question 8, and we need to calculate the real or effective interest rate on this situation. And because we've got the flat interest rate here, we can use a simpler equation to work out the effective interest rate, and that is 2n over n plus 1 times the flat interest rate. Okay, so n is the number of installment periods, which we were told was 120. So it's going to be 2 times 120 over n is 120. So we'll make that 121, 120 plus 1, and then multiplied by the flat rate, which was 10.83%. When we put that into the calculator, what we get is 2 times 120, and that's divided by 121, and then that's multiplied by the flat rate of 10.83%, and we get 21.48. 21.48%. Okay, and what comment could we make about that? Well, I guess the only thing we could say is that it's about double the flat rate, the simple interest rate, which is what we might expect, given that's what we were told earlier on, would happen, that whenever you calculate the effective interest rate, it's going to be roughly, approximately double the flat rate. And that's what we got there. Okay, in question 13, we've got a multiple choice question. A set of bedroom furniture can be bought for $2,600 cash or on hire purchase by paying a deposit of 10% of the purchase price, then $65 per month for 4 years. The amount that the customer would save by paying cash instead of hire purchase is, okay, we're going to have to work out how much they would pay if they did the hire purchase scheme and then compare that with the cash price. So the hire purchase scheme, they pay a deposit and then they pay a bunch of installments. Okay, let's work out what the deposit is. It's 10% of the purchase price, so 10% of 2,600, we can straight away see that's 260. And then plus the installments, which is $65 a month for 4 years. So it's $65 times once every month for 4 years. That's 12 times a year for 4 years. Okay, let's put that into a calculator. So we've got 260 plus 65 times 12 times 4. So when we put all of that in, we get 3,380. Okay, so that's how much we would pay under the hire purchase scheme. And we've got to compare that with this amount and see how much extra we save, or how much extra we pay. So that minus 2,600 equals 3,380 minus 2,600 equals 780. So if we pay up front in cash, then we won't have to spend this 780. That's how much money we'd save. So the answer is B. We'd save that much money. Okay, this is question 13B. Ken bought a second-hand car from a car yard. The car, with a cash price of $18,300, was bought for $5,000 deposit and weekly payments of $125 for 3 years. The total amount of interest in dollars that Ken paid was... Okay, so again, this is a kind of a hire purchase scheme, you could say. there's an initial deposit of $5,000 and then weekly payments of $125 per week for 3 years. So there's 52 weeks in a year and there were 3 years, so it's 125 times 52 times 3. That's how much he actually paid. So let's work out how much that was. 5,000 plus 125 times 52 times 3, 24,500. So that's how much Ken actually had to pay. And if the cash price was that, if we take that away, that difference between those two will be the amount of interest. So let's do that minus 18,300, and the difference is 6,200. So that's the amount that he had to pay in interest, $6,200. There it is, answer D. Okay, in question 14, Perry borrows $1,200 from a bank at 13.5% per annum. This is calculated on a reducing monthly basis. If he is to pay $120 each month in repaying the loan, calculate the number of monthly repayments that are needed to repay the loan. Okay, so this is one of our personal loan problems for which we need to use the finance calculator. So in the calculator, let's go to the main menu. How do we get back to there? So we'll go to the menu, bring up the financial solver, and we want to go to compound interest. Okay, so we're first trying to work out the number of monthly repayments. So that's the first box here that we're going to try and work out. We don't know that. We're going to leave it. We can put in the interest rates, 13.5. We've borrowed $1,200, and we're going to make some payments of $120 a month. So make sure you put a negative in front of those payments. The future value is going to be 0 because we're going to pay it all back. And if we're making monthly payments, and these two boxes are both 12. Okay, once we've filled in all those values from the question, then we can calculate N, the number of installment periods, 10.67. So 10.67 months, monthly repayments. If we're rounding it off, we could say we're going to need 11 months in the end to get them all, to pay it all off. In part B, the total amount repaid. Okay, so how much is Perry actually going to have to pay in order to pay all that off? Alright, well, when Perry's making his $120 monthly payments, we can see that after 10 of those payments, he's going to be up to $1,200. He's going to have paid off the amount of that debt if there wasn't any interest. Okay, so after 10 months, Perry will have paid off the $1,200. Okay, but because of the interest, after 10 months, there's still a little bit extra that he hasn't paid off. That's why he needs this extra 0.67 of a month to pay off that interest. Okay, so we can find out how much this money represents, this 0.67 months, by putting into the calculator. The number of payments is 10 months, the interest rate's that, he's paying off $1,200 at $120 a month, and then when we calculate the future value, how much is left after 10 months, then there's $79.43 still to be paid off. $79.43 still to be paid off after 10 months. Okay, now in that last month, he's got to pay interest on this amount of money here. So let's calculate the interest on that. Okay, so the interest on that we can calculate it according to the simple interest formula. It's going to be the principal, which is $79.43, times the interest rate, which in this case is going to be 13.5%, and the amount of time that this is happening over is 1/12 of a year, and then we divide it all by 100. Let's see what that turns out to be. So we need to go to main, and we've got 79.43 multiplied by the interest rate of 13.5, and that's multiplied by 1 month, which is 1/12 of a year, and it's all divided by 100. So we've just got to add this tiny little amount on. That's the interest that he's got to pay in that last month, 0.89 cents. Just to get it perfectly accurate. Okay, so let's add that little amount of money onto the amount of interest that we had before, and the amount left over rather, and we've got $80.32. So if we add those two together, we get $80.32. Okay, so the total amount to be repaid is going to be that plus the 1200. So 1280.32. That's how much has got to be repaid. And finally, the amount of interest paid, that was this amount here. That was $80.32. Okay, finally, last question is question 15. Mila takes out a personal loan of $4,500 to buy new furniture. The loan is 11.3% per annum, calculated on the reducing monthly balance. Mila agrees to pay $150 each month. Calculate the amount still owed at the end of each month for the first 6 months. Alright, to calculate the amount still owed at the end of each month for the first 6 months, so we're going to have 6 answers, one for each month. We've just got to put the values that we've been given into the calculator here. So for the first month, the number of installment periods will be 1. So for N, we'll put 1. The interest rate we've been told is 11.3%. The amount that was owed at the start is $4,500, and we're paying back $150 each month. So make sure you put a minus in front of that. Okay, now if we click FV, it will calculate for us the amount that's the amount of the loan, the future value after 1 month, because we put 1 in there. The future value is 4392.38. So for A, after 1 month, let's say 1 month, the value is now 4392.7.38. Okay, so that's the amount still owing after 1 month. After 2 months, let's change N to 2 months now. We leave everything else the same. And of course we had to put these as 12 because we're compounding, we're doing compounding interest every month, 12 times a year, and we're making installments once a month, so 12 times a year. So now we're doing what's the amount owed after 2 months. When we calculate the future value, it's down to 4283.74. 4283.74. That's how much is owed after 2 months. Okay, after 3 months, change N to 3, calculate the future value. We're down to 4174.08. Okay, and we'll continue on. I'll jump ahead. Okay, so here's the amounts that are owed at the end of each of the first 6 months. Okay, in part B, we have to calculate the amount of the loan that is repaid during that period of time. Okay, so since $4,500 was owing at the start, and after 6 months, there's now this amount owed. The difference between those two amounts, let's find out what that difference is. So if we had 4,500 at the start and we take away 38.36, we get 661.64. Okay, now that amount is how much we've paid off so far. This is what's remaining because we've paid off this much. So that's the answer to B. The amount of the loan that is repaid in the first 6 months is that amount. Okay, and lastly, Part C, express the amount in B as a percentage of the total repayments made over the 6-month period. Okay, so in the first 6 months, $150 was paid each month for 6 months, and that equals $900. And they want us to express this amount that was repaid in that first 6 months as a percentage of this amount. So we need to express 661.64 over 900 and then turn it into a percentage times 100%. So we can use the answer previously from there, divide it by 900 and then multiply that by 100% and we get 73.52%. And there we go. Thanks for watching the video.